This yellow square is visualizing a solar-only solution for all of North America, bringing Mexico and Canada and America to today's standard of living, 250 kilowatt hours per day per person, and we need a square almost as big as Texas. Okay, let's back off from this extreme version of reality with tiny squares in deserts, and let's visualize a plan that uses a more diverse mix. Again, I'm not recommending this particular mix. I'm going for equal amounts of solar in deserts, biomass, nuclear power, and wind, so you can see the exchange rates. On the left, I'm showing you today's consumption, which is mainly fossil fuels, oil, coal, gas. All the coal goes into making electricity, a little bit of the gas goes into making electricity, and a tiny bit of the oil goes into making electricity. Electricity is also provided by a bit of wind, some nuclear, some hydro, and then there's a few other sources of energy over here, biomass and geothermal. Let me visualize for you now what happens if you get 42 kilowatt hours per day per person from each of these four sources. Just to emphasize the scale of what we're talking about, if you were to pick 3 of these, you'd have 126 kilowatt hours per day per person, which would be reducing from the 250 to the misery of a European existence. And each of these 40s or 42s is roughly the same as today's electricity consumption alone in America. Electricity consumption in America, on average, is 37 kilowatt hours per day per person. So you can think of each of these as a visualization of how to sort out the electricity only, and if you then need to also sort out transport, you've got to do something about this entire oil stack. And there's also the gas going into industry and other things. So here's the map. This shows to scale the solar facility, which if you put it all in Arizona, would give you 42 kilowatt hours per day per person for everyone in America. It's 1/8 of the size of Arizona. The wind, 42 kilowatt hours per day per person, comes from 10 New Jersey's worth of wind farms, which also have the same area as California, if you prefer California as your unit of area. 1 California of wind power. The wind facilities could obviously coexist with the biomass facilities. There's no conflict between those. So you could superpose those 10 New Jerseys of wind with 10 of the biomass facilities. In total, there are 50 New Jerseys worth of biomass in order to give everyone in America 42 kilowatt hours per day per person of chemical energy in the form of bioenergy. Finally, the nuclear power I haven't visualized very well. The statement I should make is that you would need a 5-fold increase in nuclear power over today's levels to deliver roughly 42 kilowatt hours per day per person. So this is the country view of the sort of options that need to be on the table in order to visualize life without fossil fuels in America. Let me finish by visualizing in a more personal way what these 4 choices could look like. So instead of these country-sized and state-sized maps, let's personalize and describe what a community would need to do. The wind. To deliver 42 kilowatt hours per day per person for you, you need to gang together with 299 other people. 300 people together need to buy one of these 2 megawatt turbines and put it somewhere windy. And I think that's imaginable. I think we could do that. 300 people could decide to do that, and that would get them on their way to some target of 42 or more, whatever we want to aim for. Nuclear power, you have to talk in millions in order to visualize the exchange rate, I'm afraid. So the population of Portland, Oregon is about 1 million people, and you would need 1 nuclear power station for those million, or is it 600,000 people. Los Angeles would need 7 nuclear reactors to deliver 42 kilowatt hours per day per person. San Diego would need 2, and so forth. The biomass, to get 42 kilowatt hours per day for 1 person, you would need 4,000 square meters, which is half of this football field, devoted to 1 person. Solar power in deserts. There's a company called eSolar in Pasadena. They make these beautiful solar power stations made of little mirrors. Each mirror is 1 square meter. To get your 42 kilowatt hours per day, you need to buy 30 of those mirrors and their controllers, 30 square meters for you, and a 1/400th share of the tower that goes in the middle. So you'd gang together with 400 other people for that. So that's a visualization of what we're talking about. I do think this is possible, but it is perhaps bigger than people often talk about. So, in summary, getting off fossil fuels isn't going to be easy, but it is possible, and it may even be fun. Thank you very much for listening.